We are glad to welcome you from the University of Geisenheim. My name is Michael Wallbraun. I guide you through today's session on the topic measurement of sulfurous acid in wine by the Ribbe method. In the following, we use the term SO2 for sulfurous acid. Here you see an overview of the planned procedure. SO2 is of outstanding importance as a treatment agent for wine and can only be replaced to a limited extent by a combination of other substances and winemaking procedures. The main effects of SO2 are the antimicrobial effect, the reducing effect, the enzymatic inhibition effect, and its effect to the taste. Only the molecular, unassociated form of SO2 has this effect. The proportion of molecular SO2 in relation to the total content of free SO2 depends on the pH value of the wine and decreases with increasing pH value. As the proportion of molecular SO2 above a pH value of 3.5 is very low, this requires an exact measurement of the actual free SO2 in wine. Therefore, it's very important to know the content of the actual free SO2 and the actual total SO2. In addition, the content of total SO2 is limited by law in the European Union. For example, red wines with less than 5 grams of residual sugar may contain a maximum of 150 milligrams of total SO2 per liter. The maximum content of free SO2 is not defined in numbers, but you must not smell or taste it. In countries outside the European Union exist also other maximum values. The Ribbe method is a popular, easy and cheap method to measure the concentration of SO2 in wine and is used in many countries. This method is based on the redox reaction in which SO2 reacts with iodine. Unreacted iodine forms a blue color with starch, and the appearance of the blue color indicates the endpoint of the titration. But this method also detects other substances that have a reducing effect, called radiotones. These substances retain the content of free SO2. So it's absolutely necessary to measure the radiotones as well. Here are some examples for the range of radiotones for different wine types and ascorbic acid. Which substances are radiotones? Radiotones can be from the grape, for example tannins and anthocyanins, but can also be added, for example ascorbic acid. But there also exist among other reducing substances in a wine. So radiotones are found especially in phenol-rich, deeply colored red wines, but also in white wines to which ascorbic acid has been added. Especially red wines and white wines with added ascorbic acid should always be tested for radiotones after the first SO2 addition. If you want to check the content of added ascorbic acid, you must measure the radiotones before addition. Then you have to measure them again after the addition. The ascorbic acid content can be calculated from the difference between the two values. We will show this later. Without compromise, the radiotones and the actual free SO2 should be measured at least 2 weeks before bottling. Only in this way you can reach a high enough and stable free SO2 content. Now we would like to show you how we apply the Ribbe method in our daily practice. We will measure the SO2 and the radiotones in 2 white wines as well as in a red wine. Both white wines originate from the same barrel. Afterwards, one part was produced without, the other part with ascorbic acid. Let us start with the first white wine, the one without ascorbic acid. For the measurement of the free SO2 we need the following equipment. To dose the wine: an Erlenmeyer flask, a pipette, for exactly amount of wine, a Paleus bowl. For dosing the reagents, a dosing device for sulfuric acid, a dosing device for starch, and a burette for the iodate solution. First put 25 ml wine in the Erlenmeyer flask. If possible, the wine should be at 20 degrees Celsius when measured. Then add 5 ml sulfuric acid and 2 ml starch solution to the wine. Titrate immediately with iodine solution until blue. The blue staining must remain for 10 seconds. In this case we used 5.7 ml iodine solution. The consumption of iodine solution in milliliter multiplied by 10 corresponds to the content of free SO2 in milligram per liter. So we get the result of 57 milligram free SO2 per liter included radiotones. Here you see an overview of the procedure. Now we want to know the content of radiotones. The determination of the radiotones is very simple. In another approach we use the same equipment, plus an aldehyde, in this case glyoxal. Glyoxal is able to quickly and firmly bind the SO2. Put 25 ml of the same wine in the Erlenmeyer flask. Then add 2 ml glyoxal to the wine. The flask is left to stand for 5 minutes. After 5 minutes, the iodine titration is carried out in the same way as before. Because the SO2 has been bound, only radiotones are detected. Add 5 ml sulfuric acid and 2 ml starch solution to the flask. Titrate immediately with iodine solution until blue. Titrate immediately with iodine solution until blue. The blue staining must remain for 10 seconds. In this case we used 12.7 ml iodine solution. The consumption of iodine solution in milliliter multiplied by 10 corresponds to the content of radiotones in milligram per liter. So we get the result of 7 milligram radiotones per liter. The difference between the first and second titration gives you the value for the actual free SO2. Here see an overview of this procedure. Now we want to analyze the second wine, the wine with the added ascorbic acid. Our procedure is the same as for the first wine. Put 25 ml wine in the Erlenmeyer flask. Then add 5 ml sulphuric acid and 2 ml starch solution to the wine. Titrate immediately with iodine solution until blue. The blue staining must remain for 10 seconds. In this case we used 8.7 ml iodine solution. Now we measure the radiotones. Put 25 ml of the same wine in the Erlenmeyer flask. Then add 2 ml clear salt to the wine. The flask has to stand for 5 minutes. After 5 minutes, the iodine titration is carried out in the same way as before. Because the SO2 has been bound, only radiotones are detected. Add 5 ml sulphuric acid and 2 ml starch solution to the flask. Titrate immediately with iodine solution until blue. The blue staining must remain for 10 seconds. So we get the result of 37 mg radiotones per liter. The difference between the first and second titration gives you the value for the actual free SO2. If you compare both results after subtracting the radiotones, you will see the same amount of actually available free SO2. If we had not measured the radiotones, we would have a completely different result. In this case, we would assume a SO2 content which is not really present. If you also want to calculate the content of ascorbic acid, you have to multiply the difference between the two reduction values by 2.75. Next, we want to measure the content of total SO2. For this measurement we need the following equipment: to dose the wine, an Erlenmeyer flask, a pipette for the exactly amount of wine, a Peleus bowl. For dosing the reagents, in addition to the measurement of free SO2, we need a dosing device for sodium hydroxide, a dosing device for sulphuric acid, a dosing device for starch, and a burette for iodine solution. We put 25 ml of the wine without ascorbic acid to the Erlenmeyer flask. To measure the total SO2, the bound SO2 must be released first. This is done by saponification with sodium hydroxide solution. The measurement is similar to the titration of the free SO2. If possible, the wine should be at 20 degrees Celsius when measured. Then we mix the wine with 5 ml sodium hydroxide. The flask is left to stand for 15 minutes. After 15 minutes, the iodine titration is carried out in the same way as before. We add 10 ml sulphuric acid and 2 ml starch solution to the flask. Titrate immediately with iodine solution until blue. The blue staining must remain for 10 seconds. In this case we used 12.3 ml iodine solution. So we measured 123 mg per liter of total SO2 included radiotones. To calculate the actual content of total SO2, we have to subtract the radiotones from the measured values again. Here you see an overview of the procedure. Let us now consider the measurement of a red wine. A red wine usually contains more radiotones than a white wine. These can be tannins or anthocyanins, for example. This also depends on the grape variety. In principle, the measurement is carried out in the same way as for white wine. However, the darker wine color can cause difficulties with the Ribber method. With red wines, especially those with very strong colors, it's more difficult to identify the point of transition. The use of a light source may help. An optimized solution is a titration with electrometric endpoint determination. Also, this method requires a bit more equipment. It makes the measurement much easier. You can use it for all kinds of wine. We use the redox electrode instead of the starch solution. Now we want to measure the free SO2. We put 25 ml of the strong colored wine in the Erlenmeyer flask and add 5 ml sulphuric acid to the wine. Then we place the electrode in the flask. Using a magnetic stirrer we move the liquid. Now we have to watch the display. If the value does not increase anymore, we start titration of the iodine solution. The displayed value now decreases. When the value decreases rapidly, the endpoint is reached. So we get the result of 52 mg free SO2 per liter included radiotones. On the left side you see the wine before the titration. On the right side you see the wine with the blue staining after titration. As you can see, there is no difference. Now we measure the radiotones. We put 25 ml of the same wine in the Erlenmeyer flask. Then add 2 ml Glyxal to the wine. The flask is left to stand for 5 minutes. Then we add 5 ml sulphuric acid to the wine. Then we place the electrode in the flask again. Using a magnetic stirrer we move the liquid. Now we have to watch the display. If the value does not increase anymore, we start titration with the iodine solution. The displayed value now decreases. When the value decreases rapidly, the endpoint is again reached. So we get the result of 32 mg radiotones per liter. The difference between the first and second titration gives you the value for the actual free SO2. We calculate an actual content of 20 mg free SO2 per liters for this wine. So you see again, radiotones pretend the content of free SO2. If you want to know the actual content of SO2, it's absolutely necessary to measure the radiotones as well. We say goodbye now. Thanks for watching. We hope you can use our information in your daily practice. Best wishes from the University of Geisenheim.